Welcome everybody. Today we begin a focused and insightful discussion on a subject that play a critical role in our industry. This lecture will guide you through essential concept and practical application related to the reboiler. This important equipment which attached all time to the distillation tower, to the stripping column, you can find easily in the normal distillation unit, in amine regeneration unit, in sour stripper towers, whatever the unit you are working in refinery or gas plant, you will face the reboiler. So we will discuss in brief the reboiler type, definition and advantage, disadvantage, and we will make a comparison between each type simply. Let's go through our lecture with the definition of the reboiler. A reboiler definition: reboiler is a heat exchanger device used at the bottom of distillation or stripping column to provide the heat necessary to vaporize a portion of the bottom liquid. So you need to add heat or Q to vaporize part from the feed going to the distillation column or the stripper tower. The vapor generated in the reboiler rise back into the column and supply the stripper or the separation with the separation energy required to remove the lighter components. Look here to this tower. For any normal distillation tower, we have two parts: down the feed entry and above the feed entry. In the bottom here, we have the stripping section, which is famous. If we did not add this reboiler, you will find a little number from the theoretical trays, but add reboiler, add theoretical number of additional trays, okay, make vaporization, add Q to the bottom, down the feed entry, and let the vapor go back to the distillation column, okay. This make more efficiency for the distillation. Also, if you remark this section above the feed entry, which is rectification section, you will find here we put a condenser. Why we put a condenser? To withdraw some of this Q to make condensation and return with the reflux back to the top of the column to adjust the temperature at the top of the column and make more rectification for this part. It is considered another theoretical tray. So if I ask you about the number of trays related to this tower, 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is a theoretical number of trays when we discuss the distillation column. Okay, so the key point in the definition we mentioned that the reboiler add heat to the column bottom. It boil part of the liquid and generate vapor. This vapor return back to the tower and continue the journey of vapor liquid equilibrium related to the temperature of each tray. The generated vapor provides a driving force for mass transfer. It maintains temperature profile of the column and it can operate through natural circulation or forced circulation, as we will see next. So we describe simply the distillation column, normally two parts, above the feed entry and the bottom of the feed. This is the stripping section and this is the rectification section. In the stripping section, we need to add Q. We need to add little heat. Why? Because this is the heavier component. So we need to strip more volatile component. We need to add another tray here. How we will do this? By adding Q, adding reboiler. So what is the type of reboiler? There's many types of the reboiler. And what is the advantage of each type of them? And how to select each type of the reboiler. The general purpose of the reboiler is to strip lighter component from a heavy liquid. Okay? But for this reason, you find in amine regeneration unit, in the sour water stripper unit, some kind of reboiler. Why? Because you need to strip lighter component. In this case will be H2S and the lighter component from the water, okay? From the heavy liquid, which is the water. This is in the case of the sour water stripper, for example. or amine and H2S in the amine regeneration column. Okay, to maintain desired product purity. Okay, to control the column bottom temperature also, and to provide continuous vapor flow for the column. I think it's clear now. The internal reboiler. Internal reboiler here are simple type of reboiler in which the amount for, we stepped in the tower for the bottom side of the tower, the liquid side, we stabbed the exchanger. Okay, it's already stabbed like a knife. Okay, it's stabbed in the bottom liquid, so it is simple design, working with lower cost. Okay, if you see with me the design here, it's stabbed inside the liquid bottom of the tower. May if you will use steam, the steam in will be here and the steam outlet will be as the drawing. Okay, this is the general description of the internal reboiler. The most famous one, which is kettle reboiler. Kettle reboiler, you take from the tower liquid from the bottom and you insert it here, then you will expose this part from the liquid to steam stripping. Okay, this steam stripping goes through the tube side and went out from the as a condensate, and here the contact between the hotter side and the cooler side through the kettle reboiler happen. Okay, and there is a wall here to make carry over or overflow for the liquid to take the bottom product from the kettle itself. Okay, so the bottom product you will take from the kettle reboiler as we described here in this drawing, and some from vapor return back to the column. The only disadvantage of the kettle type reboiler is scaling and deposition of salt or something like that, solid material in the kettle itself. So the fouling need organized table to make treatment for this fouling inside the tube side and make cleaning, because it is horizontal, and the horizontal type of the reboilers generally exposed to the fouling more than the other types. Okay, here is the thermosiphon, and we mentioned the thermosiphon, we mentioned reduction in the cost a little bit. Why? Because we use the driving force of the bottom of the tower to generate the natural circulation. Here I have a pressure and the liquid head, which mean pressure, go with this force to the reboiler. Okay, the reboiler tube side, steam in and the condensate out. Then I have some from the vapor and the liquid, they gain some amount of heat and they return back to the tower. So the thermosiphon, they don't require any external equipment for the circulation. This is the key or core point. The thermosiphon reboiler did not require any additional or external equipment. Okay, here another type, which is fired reboiler. For sure we will use pump to take part from the bottom liquid of the tower and send it to the fired heater and return back with liquid and vapor to the bottom section of the tower. Okay, normally it used or you will see this type of reboiler when you are working with more viscous liquid. More viscous liquid need tool, machine to circulate the liquid from the hot equipment like reboiler or furnace or something like that, return back to the tower, because the natural circulation or the thermosiphon type will not be satisfying this criteria with the viscous liquid especially. Okay, the pump is used to circulate the fluid in a reboiler, or if you need to add a huge amount of Q, which will not be available from the steam and will not available from the reboiler itself working with the fluid, liquid oil or something like that. You need more Q, so you use the fired heater as in the drawing. For the forced circulation, I don't have a fired heater or furnace, but I have exchanger working with pump. Part from the bottom liquid go out as a product, and part calculated return back to the reboiler, generating liquid and vapor return back to the column. Okay? If we need to make a simple comparison between each type we mentioned, you will find the kettle type from the circulation side, from the heat transfer side, from the fouling, handling and maintenance, and the typical use. So you will find, if you remark the kettle type, used in the amine regeneration and sour water stabilizer. Look, why? Because the maintenance easy, fouling excellent, okay, for me not excellent. The fouling in the kettle is, for me, is heavy, and heat transfer is moderate, and the circulation pool boiling, which means like basin, and you make the boiling inside this basin. Okay, there is two types from the thermosiphon: vertical or horizontal. The vertical, the circulation naturally, okay, and heat transfer is high. Here the vertical moderate when we discuss the fouling, but the horizontal is lower. You will use the vertical in hydrocarbon strippers, lighter hydrocarbon related to when you select the horizontal thermocycle. Okay? Forced circulation. So what is the circulation tools? Circulation tool will be bomb. Heat transfer, here is high, and the fouling is here is excellent to because you have forced circulation. This means that you have a higher velocity, and the fouling maybe not matching. Okay, maintenance hard, mini connection. Okay, mini spools. Okay, it's complete system for the bomb to circulate. So for the maintenance activity, it's hard, and for the typical use for heavy oil and residue. Okay, the internal steam coil or stabbed type, here no external circulation because all the equipment inside the tower itself. For the heat transfer, it's low or moderate. Fouling is low, and maintenance is very difficult. Why? Because part or completely, not part, completely the equipment inside the tower. Okay, so you need to shut down all the tower, okay, and remove this part to make cleaning or something like that, or return back to the tower. But for the kettle reboiler, for example, if you are working with two kettle in the bottom of the tower, and this is design already in the field available, okay, two type, you can isolate one kettle reboiler and work only with another, and when you isolate, you make chemical cleaning and remove fouling and something like that. This is a simple comparison between each type from all. What is the advantage comparison for the reboiler? Like for kettle, stable boiling, handling for fouling, and easy tube remover for the kettle reboiler. For the vertical thermosiphon, high efficiency, no pump required. This is the advantage. For the horizontal thermosiphon, efficient and suitable for large duty. Forced circulation is best for viscous. Remember this. If you take this information from the lecture, it will be good. Forced circulation, when you use the forced circulation, when you are dealing with viscous liquid, okay. Internal coil, low cost for sure. Internal coil inside the tower, low cost, and this compact the design for sure when you calculate the final cost or the capital cost of the project. Here the disadvantage for each type. Like the kettle, large footprint and higher cost, because when you see the kettle type in the side, for sure you will see that you consume large area from your site. Okay, if it is limited like the offshore onshore comparison, it will be critical. Okay, so this is what we mean by large footprint. Vertical thermosiphon needs sufficient static head, because to drive this natural thermosiphon, you need special pressure inside the tower and enough liquid head at the bottom of the tower. This is the disadvantage of the vertical. But for horizontal thermosiphon, you will face more fouling and need good distribution. For the forced circulation, high cost. Why? Because you add pump with all the tools related to the pump to make this forced circulation. The disadvantage of internal coil, hard to clean low efficiency and hard to clean. Okay, so when we talk finally about the selectivity, generally the best boiler related to clean hydrocarbon is vertical thermosiphon. Moderate fouling, kettle horizontal thermosiphon. Heavy oil or viscous, forced circulation. And the amine stripper. For the engineers working in the amine unit, amine stripper recommended to work with kettle reboiler. Small gas plant stripper, it can be internal reboiler. At the end of this lecture, I want to thank you all and appreciate your good listening. Thank you.